All right, so this is the question that I was kind of facing, in my opinion. Uh, I would say difficulty or something. The reason for that is because this question is having two approaches. All right, uh, I couldn't understand the second approach, wherein you don't care about, like, the first approach talks about, the left and the right peak, and then the second approach talks about just caring about the one peak because other is going to be at a height or something. I never understood that. So yeah, let's try to implement it with the you know initial approach that I looked. Of course, I couldn't do it on my own, this question. Initially, when I started to do this on my own, I was messing up between, uh, what do we say that, I was trying to do this question according to next greater element, or next smaller element, previous greater, previous smaller. But then I realized that if I try to find out the next greatest, it won't be able to find out the greatest. And if I try to find out the next smaller, same thing goes for the previous ones as well. If I try to find out the next smaller, then it would make no sense, because for this it's 0, next smaller is this. So I mean, this won't make sense because I still have this, I can store water till right here. So yeah, so that was like the place where I was confused, like, what approach should I have while working with this question. So the thing that we are going to implement at the moment is, we will be having a left max array and a right max array. All right, we'll be having a left max array, and then we'll be having a right max array. And uh, let's do the question while we talk about it. I'll be having int left max, new int. Cool. Wait, what just happened? Wow. Uh, what did just happen? That's fine. So, what is happening? How on Control Z am I deleting tabs? Wow. I should see what comes in place of Z in like the French keyboard, because if it's like that, it's cool. It's good. I mean, yeah. But this wasn't the question. Wait a second. I mean, I can go to the profile, but it's fine. Trapping rainwater. All right. Cool. Cool. Yeah. So we have left max, and then we have right max. Here we have n. Here we have n. What does n stands for? N stands for height dot length. Cool. N stands for height dot length. And then what do we have next? We will be assigning like, suppose we need left max. All right, when we need a left max, what we need to do is we need to figure out, like, all right, when we require a left max, what we need to see is that what is the element in the left for that particular element that is greater than that. Yeah, so we'll set left max initial element as height initial element. Fair enough, because initially there can't be anything on the left of the initial element, so that has to be done. Then we'll have a for loop in which I'll say n cool. I'm gonna say that for every element I'll say it for 1 because I covered 0. Now what's gonna happen is I'll say that alright, for the element whatever I'm talking about at the moment, for example, we are right here, we start I from right here, we are gonna say that is this greater than the initial one. How do we do that? We're gonna say math dot max, and we're gonna find out that what's greater is left max I minus 1, is left max I minus 1 greater or height I is greater. So what's gonna happen is left I minus 1 would be left 0, that is height's 0. We have assigned it that, so if it's gonna check if 0 is greater or if height's 1 is greater, because left max is something that we are creating at the moment, so we don't know about it. Cool, we don't know about it. So for example, like left dot max initial 0 we set. Cool, we set what is gonna be the 0th element, or the first element into the array, and then we say that we need to find out what is the maximum. Is this the maximum or is the next element the maximum? Yeah, I mean, yeah, if this is the maximum or if this element is the maximum. Yeah, cool. What will this be doing is that we will be getting like heights 1 as maximum, so we will be getting this. Cool. So when we get this element, we know that we have a left maximum. That's the point. That's the point of the question. Left maximum means for whatever element, what's greater on its left hand side. Yeah. Initially heights. Initially we're gonna compare. So this or this is gonna get compared. Yeah. So we're gonna get this as the answer. Like, alright, this is the maximum. Yeah. Cool. This same thing is gonna get created for right maximum as well. Yeah. We would be creating this exact same thing for right maximum as well. We're gonna say that right maximum is height, right maximum's n minus 1 is equals to height n minus 1. We're gonna say now we have to start from below, so n minus 2 greater than equal to 0 r minus. Yeah, right, fair enough. Cool. So let's try to understand what the question asks from us. Question is saying that, alright, the question is saying that do one thing. What you have to do is you have to tell us that where can I store water. That's the most the question is gonna ask from us. So what we are doing is that we are, for every element in the array, we are trying to find out what is the left maximum for it and what is the right maximum for it. For example, for this element, Alright, for this element, we're trying to find out that what is the right maximum and what is the left maximum. That's it. That is all we're trying to do. We are saying that you need to have a left maximum or you need to have a right maximum. And when you have both of them, what we will be doing is that we will be saying, cool, you lie here, we will be, getting the value of it from left maximum. We will get the value of 0, 1, 2 of the second element, of the second element's left max. Yeah, we will get that value. And from the right max array, we will get the value of the second element as well. That what's the right max for it? For this, it would be index 1. For this, and for the right max would be the index 3. 0, 1, 2, 3. Yeah, index 3. Cool. Fine. We are actually here, if you see, we are actually storing the values. We're comparing the values basically. My bad. We're actually, comparing the values. That's it. We're comparing the values, nothing else. So, yeah. We'll store them. We'll have to store them. Cool. We'll have to store them. That's very basic. Where do we store them now? I'm gonna say for if left max for this is this, it's itself only. Yeah. What's the right max for it gonna be? Whatever is the right for it. Yeah. So when this is gonna come like till here, when it's gonna come till here, what we're gonna see is that let's start iterating for the left max. All right. Initially left max 0th element is height. It's 0 at the moment. Cool. We start from I1. We say that tell me the maximum between the initial and the next element. So it's gonna say this. So for this is the maximum. Yeah. So we kind of feel like just trying to find out what's going around the array. But I have a confusion in it. Like, no, it's fine. Yeah, it's fine. Absolutely fine. We're trying to find out the left maximum. So when we were at index 0, this was the left maximum. That was the number itself. When we were at index 1, the left maximum was again the number itself. Yeah. So we can just simply store this for left max of I. Yeah, for index 1 it's 1. For index 2, what's the maximum? This I minus 1 or the initial this? It's this. Cool, it's this. So yeah, we found the left maximum. Cool. Same for this. Right max I. Now whatever it's going to be. Yeah, cool. Now we have the left maximum, now we have the right maximum. What else has to be done? So now we need to figure out that we need to figure out that for a particular element, how do we measure? Let's have a int sum that is 0. Now how do we measure? That is the question. How do we measure? I guess we can have the if condition. Yeah, we can have an if condition. We're gonna say that what are we gonna say? Or can we have another for loop? I guess we should have another for loop because we need to find out for every one. For int I equals 0, I less than n, I plus plus. Yeah. Okay. So we start at the next 0. What we need to check? We need to check that if we need to check if the height I, if height I is less than or equal to left max I and height I is less than equal to right max I. Is that what we are trying to achieve? Is it? We're saying that we need to check if our height I is less than left max or equal to it, and height max is less than right max or equal to it. Thing is that this thing would execute. You see, this thing would execute. That is the problem. This thing would execute easily. What has to be done then? What can be done for the question? Suppose, let's assume this case. Cool. Let's assume this case. My left max. Yes, so if you start from here, my left max is 0. If you start from here, my left max is this only. If you start from here, my left max is this. Start from, if you are here at 2, my left max is 2. Yeah. So for index 3 it's 2. For index 4 it's also 2. For index 5 is also 2. So 0, 1, 2, 3, 4, 5, 5. For index 5, if it's 2, for this, then the right max has to be this, of course. It won't change. It's going to be 3. Yeah, it's going to be 3. So at index 5, I have my left max as 2 and I have my right max as 3. So what has to be done then? I mean, I know that. How do we calculate? How do we calculate? That's the question. We know the left and the right max. Like, you know, we know the left max and we know the right max for this particular index. How do we calculate? For 0, the thing is that it's gonna go till a particular number. That is the minimum out of the both. Yeah. if left max, wait, for particular I, for the particular I, what we can do is we can say that take the minimum from the left or the right max. Yeah, we take the minimum out of left and the right max. That's gonna be 2 in this case. How do we get 1, 2, 3, 4? How do we get 4 out of it? We get 4 out of it by alright, that's cool. We can say math dot min for left max, right max. Yeah, that's gonna be 2 for this thing. What's the index of it? 0, 1, 2, 0, 1, 2, 3, 4, 5. 5 is the index. Okay. 5 is the index. Let's try to find out the connection out of it. That's it. 5 is the index. That's what we know. 5 is the index. Minimum out of this is gonna be 2, because till 2 we can fill. That is the thing. Till 2 we can fill, no, not above it, because it will overflow then. So out of it, till 2 we can fill. 5 is the index of that particular element. So like 2 minus 3 minus 2, like so for example, what the count can be I guess I got it. Count can be right max minus left max, right max minus left max into the index. Nah, that would give 4. There has to be one thing about it. Right? There has to be something about it. There has to be a formula about it. I guess the formula is right in front of me, but I can't see it. Let's try to make it. Let's talk about indexes. Let's talk about 0, 1, 2, 3, 4, 3, 4, 5, 6, 7. Ooh. Wait, why didn't I get that before? 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. 7 minus 3, that's 4. 4 into what? Oh, 4 into the height. That is basically the value of the element, that is 0. Yeah. Like 4 minus, because, alright. For example, if at a particular place we need to put something, how much for this? How much for this? We're talking about the indexes. Cool? Talking about the indexes. So if the height is 2, if maximum it can get 2, and there is nothing to obstruct it. Cool, there is nothing to obstruct it. So for that particular one, we take the minimum. For example, I got that thing. Cool, I got the answer. 0, 1, 2, 3, 4, 5. For index 5, at index 5, how much can we put? At index 5, what's the left maximum? At index 5, what's the right maximum? Alright, the left maximum is true, the right maximum is 3. What's the minimum? That's true. So we'll talk about the left maximum then. Cool? Alright, very well. What's the left maximum? That is true. Amazing. Left maximum is 2. What is the value of the element? That is 0. That means that till 2 we can go. But from where can we start to go till 2? If you have no height, that means you can start from the bottom. That means you can start from 0. Cool. If it would have been 1, what's the left maximum? What's the right maximum? Cool. Till what can you go to get the 2 mark hit? 1. You can go just 1 above. So we take out the minimum. When we have the minimum, we subtract the value of the element from the minimum. That's cool. That's cool. Yeah. So I can say int minimum. How about that? I can say int minimum. Then I can say count plus equals count equals to count plus the minimum minus the element's value. Minimum minus the element's value. That is height I guess that should work. Index minus 1 is out of bounds for length 12. My bad. Cool. It's like if you move 1 below, you have to move 1 ahead. Alright, so that was the answer. So basically the question was all about, like, this part was easy. The left max and the right max part was easy. All we had to do was establish a relationship between how you're gonna deal with the count thing. How you're gonna get the count. So at first I was confused between the area of it, but then it was very clear about talk about the particular index, get the count for that. That's how you're gonna get the count for every other index as well. So yeah, cool. The second approach of this question talks about just 2 pointers and not caring about like basically for this question, what's the time complexity? For this question, the time complexity is 3 for loops, so it's O of 3n, which can be O of n. if we ignore the constants. And space complexity, I guess it's O of 2n. That is also O of n then. But what can be the more optimized solution? That's gonna be using, two pointers at one at the left and one at the right. I never really understood that approach. I tried, but I couldn't understand that approach. It was talking more about wherever you encounter a smaller element, you increment. So, and then you store. It was something about that. So it basically talked about that you don't need to keep the check for, you don't need two arrays or something. I don't know. I never really understood that approach, and I found that a little bit confusing. Maybe in future I'll try to do it with that. Like, we can look at a few solutions if it's possible. I guess this is that. Yeah, I guess this is that. Left max height. Left. Yeah, I guess, yeah. This is that approach. So basically, if you look about its complexity, this is its complexity can be see, O of n, pure O of n, no O of 3n like we are having, pure O of n. So it's gonna be a little faster. It's just using one while loop and that's it. While loop is gonna go till they cover complete array. Yeah. I mean, what they're doing is basically, I'll study the solution. I'll study this approach, in the right way, and then I'll try to do it with this approach as well. So yeah, for now it's O of 3n. That's O of n. A little better it could be. Yes, that's this, and that is the while loop thing. Let's see about that in the later videos. Yep.